Good morning. My name is Manikam. I am from Aeronautical A. I am going to say about metacenter and metacentric height. This topic is used for ships. The metacenter and metacentric height is mainly used for ships to avoid rotating or swinging into the water. So this is depending upon the scientist Archimedes, and he has postulated about the buoyancy, and the buoyancy is related in this one. So Archimedes' principle states that the upward force that is exerted by a body immersed in a fluid, whether fully or partially submerged, is equal to the weight of the fluid that the body displaces. So, see the experiment which is conducted by Archimedes. He kept a weighing machine. He weighed a stone, a bar of stone. It is up to a 7 lbs, 7 pounds, and he put it into water so that the 3 pounds of water was filled into this vessel. This vessel was empty before it was 7 pounds, and 3 pounds of water has been displaced from this tank to this bowl. And now we can see that it is reduced to 4 pounds. So the 4 pound force. So the weight was decreased to 3 pound force. That the water is displaced. So they state that the Archimedes principle is true. So that it states that the upward force that is exerted on a body immersed in a fluid, whether fully or partially, is equal to the weight of the fluid that displaces the fluid, that the body displaces the fluid. So buoyancy. And buoyancy states that the ability or tendency of something to float in a water or in other fluid, such as a fish floating in a water. Do you notice that due to this buoyancy concept, uh, the lightweight ships are at a different stage, and some heavy ships, and heavy fishes will be at a different place in the water levels. So, upon their weight and upon the buoyancy which is acting on them, they depend on the layers of the oceans at which fishes will be remain. This is totally the buoyancy concept itself. So, where is the center of buoyancy? Where does the buoyancy force act? Since it's a force, it must be having a direction. So, it must act at any certain point. So, the point at which the buoyancy acts is the center of buoyancy, which is stated as if when a body is submerged, it is acted upon by a force of buoyancy in a vertical direction, which is equal to the weight of the liquid displaced by the body. This buoyant force always acts through the centroid of the liquid displaced. So it is uh, stating that the force is always acts throughout the centroid of the fluid display and the liquid display. Uh, See this diagram. It said that the center of the fluid which is displayed. The center of the object which is going to be displayed. And this is the uh, difference diagram for weight and the buoyancy acting. So coming to metacenter. What is actually a metacenter? Whenever a body floating in a liquid uh, is given by a small angular displacement, so then it starts to be deflected. It must be oscillating. The body starts oscillating, and the point of oscillation is known as the metacenter. So see this diagram here, which is given in the slide. So where M is a metacenter and G is a center of gravity and B is a buoyant force acting. So upon giving a small angular displacement, the buoyant force will be changing and displace it to another new place to provide the buoyancy. And the line of action of the gravity and the line of action of the buoyant force are displaced, and so this gets oscillated. This body gets oscillated. Uh, so the intersection of these two lines, I mean these two forces, at a point is known as a metacentric point. A metacenter is known as a oscillating point uh, to make this stable. And what is metacentric height? Okay, the metacentric height is a measurement of an initial static stability of a floating body. So it can be calculated as a distance between the center of gravity of the ship and its metacenter. So it's an actual distance between the metacenter to the center of gravity of the ship. And the larger metacentric height implies that it's the initial stability against overturning straits. So this is what the metacentric height. It is simply a distance between the metacenter to the geometrical center. I mean the center of gravity of the ship. What are equilibriums in this oscillating of a body? So there are three types of equilibriums: stable, neutral, and unstable equilibriums. So upon going to the stable equilibrium, series the buoyancy changes uh, uh, from one point to another upon an angular deflection. So the metacentric is at the top of uh, center of gravity. So this states that the stable equilibrium. Uh, we can simply say that if metacenter is above the center of gravity, so that state is known as the stable equilibrium state. Neutral state. When metacenter and the center of gravity coincides each other, upon changing the buoyant force from old to the new buoyant force upon having some angular displacement of the body. So the neutral equilibrium is a point where metacenter and the center of gravity coincides each other. Coming towards the unstable equilibrium. Unstable equilibrium states that it's a dangerous situation where the overturning occurs and the ship sinks. States that the buoyant force upon going to a new place with a angular displacement, the metacenter is below the center of gravity, and this is known as an unstable equilibrium. Applications of metacenter and metacentric height. They are, they are mainly applied for ships, actually. Uh, this helps engineers to make ships boats which doesn't sink. I mean, which rescues the life of the sailors, such as before as engineering making a ship. Yeah, this metacenter and metacentric height concept will be quite easy, make easier their uh, system and the perfect system. I mean, the perfect object that is ship or a boat to be made. And submarines, in submarines also it is used, but it is not mostly used because submarine can rotate 360 degrees. But for the people who are living in that, they need a quite stable thing to stand upon a submarine on the floor. So they use this concept of metacenter and metacentric height uh, to make sure that they are in a stable nature and they doesn't tilt or doesn't oscillate. and they reduce the metacentric height. I mean, so they increase the metacentric height to get the stability. Upon decreasing metacentric height, there must be a overturning of a objects. So this metacenter and metacentric height concept is mainly used for the floating bodies. The floating bodies are mainly designed only by this topic called metacenter metacentric height. Thank you. And that's it. I want to say about this metacenter and metacentric heights. Thank you.